Hello, you're welcome back. Okay, still on nodal analysis, and here in this video, we'll be solving questions. So I have a network here before me, and the question is, okay, evaluate the battery current. So invariably now we're being asked to evaluate the current flowing through the battery. Okay, so let's call this I1. So the node now, the node I'm going to consider is node A, right? So as I1 reaches it branches, the same thing happens from battery of 7 volt. I2 actually flows to the same node. Then two of them will now branch to give I3. So this is just is simple, okay, compared to what the network we analyzed previously. Okay, this is a very simple network. All right, and the voltage also the question also asks us to evaluate the current passing through the load. The load here is RL. Okay, so that's I3. We have to evaluate the current through the load, and of course the voltage across the load using nodal analysis. So it's just a very simple, very simple. So the the current equation we are going to apply here, okay, simple, is we'll have I1 equal to, oh please pardon me, according to KCL, okay, I3 is equal to current moving away from the node A, okay, is equal to the current moving away from it. So I3 is moving away from it is equal to I1 and I2. This is I2. This, okay, this is I2. All right, and so I3 is equal to I1 plus I2. Okay, so I just have one unknown here, just one node. Okay, so that one node is going to be one unknown. That is why my KCL is just one equation. So I have just one node I'm considering. So it's just very simple, a very simple nodal analysis. So the node I'm considering is just the voltage as AVA. Okay, with respect to the negative connection, with respect to ground. So this is my ground. Okay, so let me the voltage across this load. All right, is VA, right? Is VA. So simple. Let's now go to our KVL to express this current in terms of voltage. So start with loop one. So I'm starting with loop one, right? Loop one. So you know how we go. Okay, let me go. Should I go clockwise or anti-clock? Okay, let me see. Let me go clockwise. Let me go clockwise. Okay. So if I should go clockwise in this direction, this is gonna be negative, positive, right? Going like this. Of course, this is positive and this negative is a drop. Okay, go through positive, negative, another drop. Okay, so let's do that. So from loop one, I'm gonna have 10 volts, then plus the voltage across the 1 ohm resistor. That's my node voltage, and it's from positive to negative. Okay, that's minus VA. All right. Then I now go all the way through, then I reach the 2 ohm resistor from positive to negative. All right. And the current across this 2 ohm resistor is the I1, which is my unknown, what I'm looking for. Okay. So invariably now that's gonna be it's negative. That's I1 multiplied by the 2 ohm. Okay. So that's gonna be 2I1. Okay. So with what I have now, simply I'm going to making I1 the subject of formula. I1 is going to be equal to 10 minus VA, then divided by 2. Okay, let me call this equation 2. So I now go to loop 2. You know how we do that? I will go to loop 2. I will still go, okay, this, let me go, I'm going in a counterclockwise direction. In a counterclockwise direction. So going in the counterclockwise direction, that is my battery voltage is positive, all right? Positive 7 volts. Then I enter into the branch, okay, that has RL. From positive to negative, that's a drop. Go through it again to through this resistor 3 ohms, okay, which of course is positive, still positive, and negative, another drop. Okay, so let's do justice to that. Let me use a different color this time. Let me use different color this time around. So I'm gonna have plus 7 volts. Okay, then of course minus VA. All right, then go through again, minus VA, go through again, that's minus the current through this out the current through this 3 ohm resistor is the source current, okay, I2. So that's 3I2. So that's gonna be minus 3I2. Okay, don't forget that it's equal to 0. And I didn't put that here, okay? Equal to 0. So from what I have here, it is gonna be easy for me to get my I2, right? So I2 now is gonna be equal to 7 volts minus VA, then divided by 3. So equation 3. So all I'm just going to do now is to substitute the equation 1, and substitute equation 2, please pardon me. I'll substitute equation 2 and equation 3, okay, into my KCL. That's equation, I'm going to substitute that into equation 1, okay, to help enable me get this node voltage, just this node voltage VA. So I'll go to equation 1. What is my I3? Okay, remember my I3 is actually the current across the load. And how do I get it? Okay, that's going to be voltage across the load divided by the resistance of the load. Okay, voltage across the load is VA, and the resistance of the load is 1 ohm. So that's going to be V. Okay, so I3, that's VA divided by R3, and that's 1 ohm. VA divided by 1. Okay, it's equal to I1. What's my I1 already? That's 10 minus VA divided by 2. Then plus, I'll go again for my I2. And what's my I2? Here it goes. 7 minus VA divided by 3. Okay, so it is easy now for me to get my VA. Okay, solving this equation. Of course, I can just multiply through by the LCM of the denominator. The LCM of the denominator is 6. So 6 multiplied by VA will give me 6 VA equal to, okay, 6 multiplied by 10 bracket open, 10 minus VA all over 2. This thing happens here. 6 multiplied by 7 brackets, bracket open 7 minus VA, then divided by 3. Okay, so let's do this. This is going to be 6 VA, right? Equal to 2 divided by 2 divided 6, that's 3. 3 times 10, that is going to be 30. Then 3 times VA, that is 3 VA. Plus the same happens here. 6 divided by 3, that's 2. 2 times 7, that's going to be 14. Then 2 multiplied by VA, that's going to be minus 2 VA. Okay, so my node voltage, all right, here I come. So p- have to take all the light times VA to the other side of the equation, okay? So if I move them, that's going to be minus 3 VA minus 2 VA, that's minus 5 VA. If I take it to the other side, it becomes plus 5 VA, okay? Plus 5 VA plus 6 VA, that's going to be 11 VA, okay? Then I'm going to add 30 plus 14, that should give me 44. Yeah, 44. So invariably now my VA voltage is going to be equal to 44 divided by 11. Okay, that is 4 volts. So as simple as that. So the voltage across the load is 4 volts. So remember the question is find the current across the load. Okay. So the node voltage, remember that node voltage is the voltage across the load. Okay. So invariably the current across the load is I3. You know that quite well. Okay. So the current across the load I3 is equal to the voltage across the load, which is VA, divided by the resistance of the load. Okay. Uh, so that's gonna be 4 divided by the resistance of the load. The load is 1 ohm. Okay. So that means the current across the load is 4 ampere. Okay. The voltage across the load is 4 volts. All right. So you can get other voltage. If you can get other current, if you want to get I2, simple. I2 is 7 minus V all over 3. So just in case you want to find everything, okay? I2 simply is going to be 7 minus VA, 7 minus 4, then divided by what? Divided by 3, right? Of course, 7 minus 4 is 3, so it's going to be 3 all over 3, which is 1 ampere. Okay, you can still find I1 quite well. Yeah, I1 is 10 minus VA all over 2, simple. So I1 is equal to 10 minus VA, that's 10 minus 4, divided by what? What is it divided by? Divided by 2, right? Yeah, divided by 2. That's 6 all over 2. So, which is 3 ampere. So, the question is just very simple. Okay. So, we look at more question in the next video. All right. See you in the next video. Thank you very much.